Bismillahirrahmanirrahim. Assalamu alaikum students. If you people are in first time in my channel, then please subscribe it and press the bell icon for the next videos. Thanks. So today lecture is about circular functions, hyperbolic functions and Euler identity. So we know that exponential for x is equal to e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 divided by 4 factorial plus up to so on. It is the representation of exponential for x that e power x is equal to 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial plus up to so on. And cos of x is equal to 1 minus x square by 2 factorial plus x power 4 divided by 4 factorial minus x power 6 divided by 6 factorial plus up to so on. Alternatively, there is negative and plus sign. It is the representation, it is the Taylor expansion of cos of x, Maclaurin series and Taylor series of cos of x, and sine of x is equal to x minus x cube divided by 3 factorial plus x power 5 divided by 5 factorial minus x power 7 divided by 7 factorial plus up to so on. It is the Maclaurin-Taylor series of sine of x. So there are three series. One is exponential power x, the second one is cos of x, and the third one is sine of x. So it is the first expansion A, it is the second expansion B, and it is the third expansion C. Now from the first expansion, if x changes to iota x, if x changes to iota x, then the expansion A will be e power iota x is equal to 1 plus iota x whole square by 2 factorial plus iota x whole cube by 3 factorial plus iota x whole power 4 divided by 4 factorial plus up to so on. Now evaluating the terms of this expansion, so e power iota x is equal to 1 plus iota x and iota square is equal to -1, so negative with this positive is negative, and x square, so it is x square divided by 2 factorial, and iota cube is equal to negative iota, so it is equal to minus iota x cube divided by 3 factorial, and it is iota power 4 is equal to positive 1, so it is equal to plus x power 4 divided by 4 factorial plus up to so on. Now if we see or examine the these terms of this expansion, then here is iota, here is iota, and after this terms will be iota. So if I separate the real and imaginary parts of this expansion, so it will be e power iota x, and this term will be 1 with this term it will be 1 minus x square by 2 factorial, and it will be plus x power 4 divided by 4 factorial, and after this term the term will be minus x power 6 divided by 6 factorial plus up to so on. And the imaginary part of this expansion is iota x cube, and after this term will be another term with iota. So if I common iota from the imaginary part, so it will be iota. So if I common iota from x, then from iota x, then it will be x, and here if I common iota from this term, then it will be minus, x cube divided by 3 factorial, and after this term the term will be plus x power 5 divided by 5 factorial plus up to so on. So I separate the real and imaginary part of this expansion. So e power iota x. So if I compare this with this, then cos of x is equal to 1 minus x square by 2 factorial x power 4 by 4 factorial minus x power 6 by 6 factorial. It is equal to cos of x. So cos of x plus iota and x minus x cube by 3 factorial plus x power 5 by 5 factorial. It is equal to sine of x. So iota with sine of x. So this identity is called Euler identity, that e power iota x is equal to cos of x plus iota sine of x. So it is the general identity of, it is the general Euler identity. If I change this x to negative x, if I change this x to negative x, then it will be e power minus iota x cos of negative of x plus iota sine of negative of x. Then e power negative iota x cos of negative iota x is equal to cos x, because this is even function. So cos of negative of x is equal to cos of x, and sine of negative of x is equal to minus sine of x, because this is odd function. So it will be minus iota sine of x. So e power negative iota x is equal to cos of x minus iota sine of x, and e power iota x is equal to cos x plus iota sine of x. This is the two Euler identities.